Understanding basic electronics is the lifeblood of amateur radio, especially if you enjoy homebrewing your own gear, building linear amplifiers, or troubleshooting a newly minted transceiver. The passive building blocks. These components don't require power to operate and are the foundation of shaping and controlling electrical current. Resistors. These limit current flow. In RF circuits, you'll also encounter specialized types like 10K and TC, negative temperature coefficient thermistors. These are incredibly practical in linear amplifiers to monitor the temperature of an aluminum heatsink and adjust the bias voltage to prevent thermal runaway. Capacitors and inductors. Capacitors store energy in an electric field, while inductors store it in a magnetic field. Ham applications of capacitors and inductors. Together they form tuned circuits. If you are designing a low-pass ladder filter for the 80-meter band to keep your transmitted signal clean, you are calculating specific values of capacitors and inductors to allow your 3.5 MHz signal to pass while blocking higher frequency harmonics. Semiconductors, the active engines. These components control the flow of electrons and are essential for generating, detecting and amplifying RF signals. Diodes. These act as one-way valves for current. Ham application. Beyond power supplies, fast switching diodes like the 1N4148 are crucial for building simple RF probes to measure VFO output voltages when aligning a transceiver. Transistors and MOSFETs, the workhorses of amplification and switching. Ham application. For QRP rigs, standard bipolar junction transistors are common. But if you are building a 100-watt linear amplifier, you will likely be working with rugged power MOSFETs like the IRFP 150. Understanding their gate bias requirements is critical to getting a clean linear output. Practical circuit concepts for homebrewing. Ohm's law, V is equal to I into R, and power, P is equal to V into I, where V is the voltage, I is the current, R is the resistance. These are the golden rules. If your amplifier is drawing 10 amps at 13.8 volts, you are dealing with about 138 watts of DC input power. The difference between that and your RF output power tells you how much heat your heatsink needs to dissipate. TX-RX switching. Getting a radio to switch between transmitting and receiving smoothly is a classic homebrew challenge. While many radios use a physical PTT, push-to-talk line, some efficient amplifier designs rely on carrier-operated relays with RF sensing. When the circuit detects RF from the exciter, it automatically switches the relays to the transmit position. Signal tracing and modular architecture. Modern homebrew rigs often separate different functions into modules. When troubleshooting low TX output, you have to trace the signal logically from the digital VFO output through the mixers and out to the power amplifier. It also helps to know your architecture. For instance, realizing that your audio amplifier might be located on the digital controller board like a Arduino rather than on the main analog RF board.